Okay, so good afternoon and welcome to the second lecture. So this is the second part of the second lecture. Okay, so now we're dealing with applications of integration. We started talking about definite integrals, then we moved to area, how to find the area between two curves. Actually, we found first area just given a region. Okay, so now we are moving to how to find the area between two curves. So suppose we have two curves, y1, which is just equals to f1 of x, and y2, which is just equal to f2 of x, and can have a sketch where we have and that is our y1 and this is our y2, and the point where these meet there you have A and there you have a B. Okay, so suppose that is our sketch. So these are the points where the two curves meet, and there as well. Okay, so if we have such a case, then the area of this region, the area between two curves, will be given by the integral from a to b. Remember, these are x. Then we have the y functions, y1 minus y2 dx. So that is the area. So you subtract the one beneath from the one above. Okay. So we now get into the steps. We know how to solve this, but in case we are not given the points of intersection, we need to solve the two functions using, we need to solve them simultaneously. Okay. So that is if we are not given A and B. Okay, so let's have an example. Okay, the example that we have is that find the area bounded by parabolas y squared is equal to by the parabolas y squared is equals to 8x and x squared is equals to 8y. Okay. So here, the first thing that we need to do is to find the intersection points because we don't know the intersection points. So, from the equation x squared is equals to 8y, it implies that y is equals to x squared over 8. Okay, we'll use substitution method. Then substitute. We'll now substitute in the equation y squared is equals to 8x. Okay, so then we know our y is x squared over 8. Okay, we get another, we have minus. So then we have x squared over 8 squared is equals to 8x. So this just means x to the 4 over 64 is equals to 8x, implying that x to the 4 over x is equals to 512x. Okay, so maybe let's do the steps. This just means x to the 4 is equals to, you cross multiply there, you have 512x, then divide by x, both sides, divide by x, then you have x to the power 3. Remember from the laws of indices, you just subtract a 1 from 4. Is equals to 512. Take the cube root, both sides, and you have your x equal to 8. Okay, but there is also another solution for this equation, which is x is 0. Because in the equation, you are told that y squared is equal to what? 8x. So, when you put x at 0, y will also be 0. So this also forms a part of the solutions. So for any equations where you have y is equals to x or ax, just know that 0 is also part of the solutions. Therefore, our limits are x is equal to 0 and x is equal to 8. Okay, now that we have our limits, we just need to sketch and see what the graph looks like. To sketch, of course, we'll make our box. Now remember, you have a 0. Maybe you want to find another point and you want to see what happens at 8. So for 1, for y is equals to, or for y squared is equals to 8x. What happens at 0? You have a 0. What happens at 1? You have a square root of 8, plus or minus. Okay, so let's just pick the positive part. So we just have the square root of 8. What happens at 8? When x is 8, y is also 8. Okay, so but for the other one, x 1 0 1 8. So at 0 we also have a 0. At 1 we have, this is for the other equation, 1 over 8, and at 8 we have 8. So this is for x squared is equal to 8 1. Okay, so we just get our coordinates and plot. Remember, these are parabolas, so they're not straight lines. So for the first one, we have 0, 0. So this is at 0. Maybe the other one is at 1, and this will be 8. So at 0, we have 0, 0. Then the other one could be somewhere. Okay, so let's have 0, somewhere like a 2 here, and 8. Okay, so actually when you do your plotting, you have okay, and the other one going like that. Okay, so this is supposed to pass by. Okay, so let's start all over. Okay, so I'm just trying to sketch. Okay, so we have it there. So that is our 8. And there we have our 0. And also, this is also our 8. There. Okay, so the region that we're looking for is this region. Region A. Now that we have our region, what do? We solve. So therefore, area is given by the 2 points on x, which is 0 and 8. Then we say the difference between, which one is actually linked. This one is y is equals to, y squared is equals to 8x. And the other one is x squared is equals to 8y. So the one that is on top, that is your y1. And Remember, we're looking for a y function, not y squared. So that function will be root of 8x minus the other function in terms of y, it is x squared over 8 dx. Okay, so this again is, we take out the square root of 8 and we know x squared 8 root 8 x is just 1 root x to the power 1 over 2, then minus x squared over 8 dx. Go to the next slide. We now integrate, and this gives us square root of 8 square root of 8 x to the power 3 over 2 over 3 over 2 minus x to the power 3 over 24. And we have our limits, which are 0 and 8. So okay, so then we have okay, so when you simplify this, you should get 64 over 3 square units as our answer. Okay, so just put in x, put in 8, then when you put 0 as well, the 0 terms will obviously vanish. Yeah. So actually when you put 0, this will be 0. So you just deal with the 8. So take this out. When you put 8, what we have there, and when you put 8 there, what we have as well, then you solve. Okay. Okay, so the next thing that we move to is volume. Volume, so we can as well find volume using integration. Okay, so volume of a solid. So volume of a solid generated by revolving the area of the curve y is equals to f of x, and the lines x is equals to a and x is equals to b about the x-axis. It's given by, so here our volume is just given by pi multiplied by the integral of a comma b y squared dx. Okay, so if we are revolving around the y-axis, then the volume is given by pi multiplied by the integral over c comma d x squared dy. Okay, so that is the formula that we use if we are revolving around the y-axis. But if we were revolving the area about the x-axis, then we have, this is the formula that we use. Let's have have an example. Find the volume of the solid generated by revolving the area bounded by y is equals to 2x squared, x is equals to 1, and y is equals to 0 about the x-axis. Okay, so the line y is equals to 0 is just the x-axis. Okay, so let's see the solution. So this is given by, I guess just sketch the other side. Okay, so let's just sketch. Okay, so we have the lines x is equals to 1 and the x-axis. Okay, so we have our y there. Y is equals to 0 is this same line. So then therefore our area will be this area from 0 up to okay. So this is our area. We have a 1 there and we have 0. Okay. And this is the line y is equals to 2x squared. So find the volume. We're going to say pi integral the 2 points of x, which is 0 and 1, the y function, but we have to square it. The y function is what? 2x squared, so we have to square it. Dx. This will give you pi 0 to 2, 4x to the power 4 dx. 4 is a constant, it can be taken out. Dx 4 pi x to the power 5 over 5 0 to 1. This gives you 4 pi 1 over 5 minus 0. which then gives you 4/5 pi. Now the units are cubic units. Remember, for area we had square units. Okay, so that is an example on the volume. And now move to velocity and acceleration. This is also an application. Okay, so the things that we have to note here is that S will represent displacement, which is just distance in a particular direction. V is the velocity, and A is the acceleration. Now, velocity is equal to the rate of change of displacement with time, and acceleration is just equal to the rate of velocity with time. Therefore, if we wanted to find displacement, this implies that displacement is just equal to the integral of what? Of velocity with respect to time. Okay, so put the reverse. To get displacement, we integrate. And similarly, to get the velocity from acceleration, we're going to integrate acceleration with respect to what? With respect to time. Let's have an example. Given that the acceleration of a student's car is 6 meters per second. If 6 meters per second, if velocity is equal to 3 meters per second when time is 0, find the expression for velocity. For velocity. Okay, so we are given acceleration to be 6 meters per second squared. This implies that velocity is the integral of acceleration with respect to time, which means V is equal to, what is the acceleration is 6 dt. But 6 is a constant, so V is equal to 6 integral dt. Now, the integral of 1 or of nothing is just a t. So this will give us 6t plus a constant c. Okay. Now we're given the condition that velocity is 3 when t is 0. So we can say velocity is equal to 6t plus c. But we can use that condition to find the value of c. Velocity is 3 when t is 0. We know that v is equal to 6t plus c. Velocity is 3, so we replace. When t is 0, 6 multiplied by 0 plus c, this will give us a 0. That implies that 3 is equals to c. So c is equals to 3. Therefore, velocity, which was given by 6t plus c, just means that it's 6t plus 3 because our c is 3. Okay, so this is the required expression for velocity. The final thing that we're going to do here in this chapter is look at average value of a function. So the average value of a function on an interval a comma b is just given by 1 over b minus a integral from a to b of f of x dx. Example, find the average value of f of x is equal to sec squared x on the interval 0,45. We know that the formula 1 over b minus a integral from a to b of f of x dx. So our b is 45 minus 0 integral from 0 to 45 of sec squared x dx. But the integral of sec squared x is just tan x. So we have 1 over 45 tan x 0 to 45. 1 over 45 tan 45 is 1, tan 0 is 0, and this will give us 1 over 45 as our answer. So that is the average value of a function. Okay, so this is where we end with chapter or lecture 2. The next thing that we're going to do is look at partial fractions. Okay, we're going to look at partial fractions and integration. All right, thank you so much. Please go through the tutorial sheets, and you're going to find them on the portal, as well as the questions in the module on this particular subject. Thank you very much.